Okay, this is section 8.7, volume of the sphere. Nicholas.
The annual Gatineau Hot Air Balloon Festival has been held since 1988 in Gatineau, Quebec. Hot air balloons come in a variety of shapes. One special shape that appeared at the festival was a soccer ball. This soccer ball was about 17.4 meters in diameter and could hold 385,696 ordinary soccer balls inside it. In this section, you will develop a formula for the volume of any sphere.
Good. So the investigate looks at tennis balls. Again, we don't have this apparatus here, but basically they're looking at the amount of displaced liquid by the sphere. Okay, so you put a tennis ball into a tennis ball tube, like the ones we get with 3 tennis balls in, and then by measuring the amount of displaced liquid, we can actually figure out the amount of the sphere. And by taking that amount of displaced liquid, knowing the diameter and circumference of the sphere, we can figure out the formula for sphere, okay? Which happens to be here, okay? 2/3 pi r squared times h, okay? So at the end of the day, your take home is the volume of a sphere is equal to 2/3 times pi r squared times h, okay? So let's look at example 1 here. It says Pluto is the smallest planet in the solar system. Interesting note. Is Pluto still considered a planet? No.
It's a planetoid.
Right. They've taken away its planetary status. So this shows the date of this textbook a little bit. The diameter of Pluto is approximately 2,290 kilometers. Calculate the volume of Pluto. The volume of a sphere is 2/3 the volume of a cylinder with the same radius and height equal to the diameter of the sphere. If the sphere has radius r, then the cylinder has a base radius r and a height of 2r. Okay? Any questions about this diagram? Here's our sphere, there's your radius, your height is 2 times the radius, sphere, again your height is 2 times the radius. Okay? We know that because the sphere is equal distance from the center, so to go from the center to the top is 1r, to go from the center to the bottom is another r, so the height then would be 2r. So the volume of our sphere is 2/3 times the volume of a cylinder, which is pi r squared times h. So we end up developing, sorry, I put a square over this formula. I should have actually waited until we had finished developing the formula. There is your volume for a sphere, okay? And the reason why they went through this to begin with is because that's what was used when we calculated the displacement of the water in the tennis ball cylinder. Okay, so that's why they based it on the volume of a cylinder. But at the end of the day, there's your volume formula for a sphere, 4/3 pi r cubed. Okay? So that's the one you want to remember. Okay? The radius is 1/2 the diameter. The radius of Pluto is 1145 kilometers. Use the formula for the volume of a sphere. So we take that 1145 and we substitute it in for radius. And then we solve. There's our volume. So the volume of Pluto is approximately 6 billion and 300 million kilometers cubed. Any questions? All right, last example. Spherical gemstone just fits inside a plastic cube with edges 10 centimeters. So we have a plastic cube. We know a cube, all of our sides are the same, so every side is 10. Okay, and then we have a spherical gemstone that's fitting inside there. Okay, calculate the volume of the gemstone to the nearest cubic centimeter. So what's the diameter going to be if we have a gemstone that fits right inside a cube that is 10 centimeters wide? Mark?
Radius? 5 centimeters.
Radius 5, yeah, diameter would be 10, right? I was asking diameter, but yeah, radius is 5, right? And the reason why is because the edges of that sphere, if it fits inside to this box, that's 10 wide, the edges are going to touch the edges, right? So that's why the diameter is 10. And the radius is 5. The radius is 5, we can substitute that into our nifty formula, and we calculate 524. Important, of course, to note the units, centimeters cubed. Any questions? All right, part B says, how much empty space is there? So this how would we do this? How would we go about doing this? Robert. So Robert, look here. We have a cylinder, or a sphere, like a tennis ball, right?
Yeah.
We're fitting it into a little, like, gift box. It's just the size of the tennis ball. How would you get the empty area around the tennis ball? You want to know the volume around the tennis ball. Okay. You have like a box,
Yeah.
right? A gift box. You're going to take a tennis ball and you're going to put it in the box, right? There's going to be spaces in the corner, right, where there's air.
Yeah.
How would you find that leftover air?
Solve for the volume of the box.
Yeah.
And then the volume of the sphere, and then subtract it.
Right, you got it, yeah. So if you're listening from the beginning, you would have had it right away.
I was like, so
Yeah, I know, it's okay. I was picking on you because you were zoned out. All right, that's perfectly right, though. So he's taking the volume of the box. Everyone understand this, right? So we know all of the volume in that box. Then we take the volume of the cylinder. That's how much volume it's going to take up. We're going to subtract that, and then we'll get the leftover space, right? So that's what they do. They take the volume of the cube. We know it's 10 times 10 times 10 because the volume of a cube is side times side times side. All the sides are the same. 10 times 10 times 10 minus the volume of the sphere, which we already found. So we get our leftover space, 476. So our key concepts then, the volume of a sphere with radius r is given by the formula 4/3 pi r cubed. Don't forget, this is a cube, not a square. Cube, so that's a 3 there. You can calculate the empty space in a container by subtracting the volume of an object from the volume of the container in which it's packed. Any questions?